Namaste. I, Simran Kaushal, welcome everyone on the brand new episode of Science Bits only on Bharata First. This season is all about science, which is simplified in a short, crisp, and a unique manner by the experts. This platform provides a unique opportunity to explore your scientific temper and skills. Science Bits involves explanation of the topics ranging from the recent trends and developments in the field of science and technology to the discussion of the previous year questions and potential concepts which are important from the perspective of competitive exams. Let your curiosity out and ask questions through a form whose link has been provided in the description box below. Do make use of this opportunity. Now, I would like to introduce to our science expert, Dr. T.V. Venkateshwaran, who is here with us to answer the questions. Dr. T.V. Venkateshwaran is a senior scientist at Vigyan Prasar, New Delhi. He is also founder of India Science Wire. So, the first question for today is,
See, there are various kinds of debris that can come from plastic. Okay, so when you have big plastics, okay, something above a meter, like a can or a net, that kind of stuff. Okay, these are called megaplastics. So, what can these megaplastics do? For example, in a net or a big polythene bag, a big animal can get trapped. Okay. Then you have macroplastics. Macroplastics are between 1 meter and 2.5 centimeter. So bottles, our carry bags, all come in that macroplastics. So in the macroplastics can again entangle with animals or creatures in the marine environment. It can affect the biotic issues. Then you have something called as a mesoplastic. Mesoplastics are like, say, for example, the Bristol. Okay, they are all very tiny, right? So it's basically about 2.5 centimeter to about 5 millimeter. Then you have the microplastics. So the microplastics are things which are less than 5 millimeter. Okay, so to answer what is microplastics in a very simple way, they are all plastics which are less than 5 millimeters. Okay, so this 5 millimeters can accumulate, and then it can be eaten by animals, and then there is something called as a bioamplification can take place. In addition to microplastics, today people are talking about nanoplastics. So anything less than 1 micron is considered as a nanoparticle, nano plastics. Okay, so these are all the various kinds of plastics. Today, what we are doing is that we are producing plastic. Okay, at that time there is a spill, so there is a pollution. We are using plastic. After plastic, I mean, we litter. That litter goes into our environment. Okay, then waste is collected, waste is put in landfill. That landfill leaches and then takes it to the environment. So there are the way plastic is goes into our environment is at all the stages: production, use, and waste treatment. All stages it is there today. Okay, so microplastics are plastics which are less than 5 millimeter, as I said that. It starts with the plastic littering. Okay, this plastic littering becomes with the sun's ultraviolet rays, or maybe mechanical or maybe microbial. All this acts, and then these plastics are fragmented into microplastics. So when it becomes microplastics, it's less than 5 millimeter. So it can mix with soil, it can mix with water, it can be leached into a water body. Then a fish eats it. So the seabird which eats the fish gets a lot of microplastics. Similarly, aquatic life which eats the fish gets a lot of microplastics. And then when we fish and use that fish, the microplastic come back to us. Okay, so this is a cycle of microplastics we see around. How to stop this? How to stop this is to go for what is called as cycle economy. Okay, what is it? Whether it is in production or use or waste, you cycle the material, right? So there may be a small amount of spill, but then reduce it as much as possible. And then after that, uh, uh, littering you stop, you arrange for recovery by, let's say, paying for old bottles and so on and so forth. Okay, and then the waste, instead of throwing it away, use it for recycling or conversion into other products. So this kind of a circular economy, where we are not throwing anything away as actually waste. We may be throwing it away as waste from a particular process, but that should become an input for next process. So if you do it like that, then the microplastics can be substantially controlled.